My name is Oleg Šelajev. I work as the developer relations person at a company called Atomic Jar. Atomic Jar is a small startup. We're around 25 people, made by the maintainers of the Testcontainers libraries. We are almost 2 years old, more or less 2 years old, depending on which dates you're looking at. And what we are doing is we are building two things. Right? We continue to push forward and develop and maintain the Testcontainers libraries, which are the open source libraries simplifying testing your applications. And we also now have a service which is called Testcontainers Cloud, which is the on-demand cloud platform that you can use to run the containers when you're using Testcontainers for your tests. It's currently in the public beta, so you will be able to try it. Somewhere in the slide deck, there is a slide with the QR code. If you can spot it and can take a picture, it will get you to the sign-up page immediately. So you can get that. If you would like to build those amazing things, either the cloud or the libraries, we recently announced that we raised money, and we are now hiring people at different positions. So if you're looking at that, you can contact Sydney. She's great. She's our HR person, and you can talk. Right, let's go to testing. Software development cycle consists of many things and many activities. How many of you are mostly developers and like sort of write code like 3 days a week? At least three or more. Some days are lost due to meetings, but if you write code 3 days a week, I personally would consider you a developer. And as we know, there are more to software development than just writing code. There are also the whole operation side, but more or less, the full cycle looks like this, whether you are actually practicing the DevOps processes and methodologies or not. And one very important part of it, which not that many actually people talk about. So a lot of sessions and information is about operations, how to do things, how to run things in the cloud, how to monitor things in the cloud, how to use observability. A lot of attention is on actually coding part of the activities. And currently, for example, the security is a very big topic, so it goes somewhere under the build. But in this thing, there's also test, which makes people go like, what? Because nobody likes to test. Well, everyone sort of understands the value of testing and the value of having good, reliable, automated test suites. But very often people disregard that as a less important activity, or maybe just don't have the tooling to test their applications in a way where tests don't just exist, but they actually provide you with value, which is very, very clear. Right? We love tests. We know that tests should be kind of sort of like an academic paper. I was at the university, and then I dropped out when I couldn't manage. But I know that if you want to publish like a good paper, it needs to have 3 things. It needs to be novel, it needs to be significant, and it needs to be reproducible. Right? And this is exactly what you want from your tests. Every test should potentially verify a new piece of behavior. It doesn't make sense to verify like the same behavior that it works with different tests, that's just spending time and resources. Test needs to be reproducible, because if they're not, you cannot use that as a signal whether your stuff works or not, and this becomes like impossible. And test needs to be significant, which means is that the results of the tests should be taken into account. If your build is red, if your build is failing, you should do something about it. Like maybe not release that into production. And if your tests are green, ideally, that should be a strong enough signal that your stuff works. Very often people write tests, and they run the tests, and the tests are green, but it still doesn't give you developers the confidence to actually say, like, yeah, my stuff works. My tests are green, it means my stuff works. And think about this. And this is a little bit off topic, but just as a food for thought. If you run your tests, and they're green, and that doesn't tell you that your stuff works, why do you run them? It's a conundrum of sorts. Right, so we'll have tests. There is the libraries that simplify testing for your applications called Testcontainers. Very popular, exist in different languages. So we have currently Java, which is the oldest and most advanced, I think, at the current moment, implementation of the Testcontainers. But there is also Testcontainers Go, Testcontainers.NET, Testcontainers Python, Testcontainers Node for JavaScript developers or TypeScript developers, Testcontainers Rust. I think recently we were joined by Testcontainers Haskell, which is very interesting for me personally, that even the Haskell ecosystem wants to run tests. And the whole idea, what Testcontainers does, is that it allows you to run your unit tests, but with real dependencies, or as real as possible, to give you the strong confidence signal if stuff works or not. What it does on a more developer-friendly level, it gives you the programmatic API to run anything that can be run in Docker containers. It gives you the ability to instantiate, configure, and manage the lifecycle of the containers from the tests from within the tests. It gives you a number of benefits. First, programmatic approach is obviously superior because it's flexible. Second, the configuration, so the test itself can declare what environment it wants to run in. That means it doesn't depend on any third-party configuration or service providers. And it can run the same way on your workstation, in your CI environment, on your colleague's workstation, whether there is operating system mismatches or architecture mismatches, because the test itself says, I would like this. Here's a very short example outlining the basic and most fundamental API called generic container. It's an abstraction that allows you to run anything, in this case, Redis. And then Testcontainers libraries will take care of the next things, and it will give you the ability to do the container lifecycle management, starting, stopping containers, and the cleanup, which is very important for repeatability of the tests. We automatically remove all the containers, even if your tests fail, even if your tests crash, the containers will clean up, and then it will not be the situation where you run your tests, or even worse, your colleague will run the tests, and then instead of connecting to their services that they want to test with, the test will find an instance of Kafka that is running for 2 weeks because you forgot to clean it up, and then their tests fail, and then they spend 3 days debugging it, and then they will figure out it's your Kafka who's messing stuff up, and then they will come to you to have words. They will look at you very sternly and say, you need to clean up. So, configuration, container lifecycle cleanup, API, programmatic API for configuring both containers and application within the containers. For example, if you're running a database, you might want to say that, oh, I'm going to use that database through a network interface, so I need to expose some ports in the container. And also, I would like that database to have my schema, because database without any data is kind of pointless. So you need to be able to configure both the containers and the applications, and there is an API for those things. And also, Testcontainers provides you with integration with the frameworks, which is, in case of Java, would be the application frameworks like Spring, Quarkus, Micronaut. How many of you do sort of web application development? Mostly? How many use Spring, people? Most of you? Not a lot. Quarkus? Daniel, very good, very good. Micronaut? Who is just sleeping? Very good, very good. No, there are also other projects. Some people are dealing mostly with libraries. Some people are, for example, maybe DevOps or platform engineering specialists who do not develop applications, but could be still interested in this. But for the library purposes, we need integrations with frameworks. Those would be application frameworks or unit testing frameworks like JUnit or Spock in the Java ecosystem. And what is good about Testcontainers that it comes with the ecosystem of modules. I'm going to show you. I'm going to show you the whole ecosystem of modules. All those wonderful logos I'm going to go into the Java version, and we're going to go into the modules part here. There are predefined abstractions for all popular databases, for other technologies, for message brokers like Kafka's, and for mock servers, for RabbitMQ, for Redpanda, for Elasticsearch. Those abstractions, they are pluggable into your code as libraries, and they give you abstractions that allow you to spin up and request a certain technology to be created in a container without actually configuring it or knowing how to run it in the container. I don't know how to run Kafka in the container, but what I do know is that if I go to my Testcontainers library for Kafka, then I can just include that, and then I can just say, give me a new Kafka container, and there is a Kafka container. So it works very, very well with sort of standalone technologies like databases or message brokers, because they're very natural. There is a very natural way to run them in containers. You can run an Oracle database instance in a container, and you know that when your tests use that for their configuration, the test is meaningful. Well, if it does something meaningful as checks and behavior validation, it is meaningful because it runs against the actual real stuff that you're going to run in production. So there are no mocks. All the code paths are still executed. There are no additional weird configuration. There are no embedded services that you use to mock, say, a database like H2. So it's the real thing, and you can run high-level integration tests that verify that your application works in an environment very similar to the production. And that works great. And I can show you a quick example of that maybe, which maybe don't, because I restarted and then everything closed. OK, I will show you. I will reopen this very quick project. View, appearance, enter presentation mode. Very good. So for my application tests, I can declare a number of containers. I can build any complex topologies of the containers, put them in the networks, do manipulation, and I have the API to do all necessary configuration. What's great about that is that my API is actually on the language level, which means that you don't have to know what you can do with those containers or those particular modules, but your IDE will tell you. And you can configure everything from the environment variables to the actual commands that you want to run for the Docker containers to various configuration of which ports are exposed, which files need to be copied in there, and so on. Here's a simple example of a Spring application that requires Postgres, that requires Redis and Kafka, and you can run this. All those abstractions, like the Postgres container they come from the libraries, from the Testcontainers modules. And I think I can just run this test suite. I'm not going to run it because that is not what I wanted to show. Right, I'm going to skip that part for brevity. I could run the tests. They will create me the containers, run it in Docker environment, specify the configuration, put my schema, run the tests, all good. So now the question is, but we don't only have, not only we have like the standalone technologies like databases or message brokers, there are also cloud applications that rely on various cloud technologies, right? You might be using AWS. There are no reactions from AWS people. They're sleeping. You might be using Google Cloud. You might be using Oracle Cloud or any other cloud that provides you with the technologies. It could not. It doesn't have. It doesn't need to be like a generic cloud provider. It could also be just a single-purpose cloud solution that provides you with a managed instance of something, and you still sort of need to test against that. And this is harder to do, and this is non-obvious, and many people don't know that there are still tools that can give you the best of both worlds. The unit test-like experience, where you can run your tests from your IDE with the completely contained configuration and run with the as close to the real thing as possible. Right, so let's do it. There are a number of different there are actually 3 different types of services that you would see. The first type is the simplest. It's the managed services where the cloud service is the clone or a managed version of some technology. So Oracle Autonomous Database is an Oracle database, but it's managed by the Oracle Cloud. Neo4j Our DB is the Neo4j graph database thing that is managed by Neo4j. PlanetScale is MySQL, serverless or just managed, probably the biggest, or I don't know, the MySQL version in the cloud. MongoDB has the MongoDB cloud. Most of the companies have them. Elasticsearch has Elasticsearch in the cloud managed platform. And then those you test very naturally. You know that there's the copies of the databases that you can run in containers. So you can still use the normal modules for verifying behavior against those services. So that is the least interesting case. The more interesting case is when there are services that the cloud provides, but they are not available as a standalone things. For example, you can have a Google Spanner database or a Google Firestore, and they are not, well, there is no local version of Spanner. That is, it doesn't make a lot of sense because it is the distributed highly available database, but it's also, it has a unique API, it has the unique drivers that the application needs to test. So what is possible is that the cloud vendor provides you with the emulators that you can run locally. In case of Google Cloud, they have emulators for the Cloud SDK. And Testcontainers module, GCloud module, we have a module specifically for that, integrating with those technologies offered by Google Cloud. And you get the abstractions. So Google or the cloud vendor maintains the emulator, the Docker container, where they run the emulator. So you know that there is a high confidence levels that this is actually the real thing. And the test containers provide just the configuration with that. So if you, for example, want to test a Google Cloud Firestore, what you can do, you can import the Maven dependency into your project. And then you, the same way as you create any other technology, you would say, oh, I would like my Firestore emulator. And that is the abstraction that the test containers module gives you. And you specify the Docker image that you want to run. That one is managed and created and published by Google. And then the other thing is we can spin up the container. We can manage the lifecycle. We can start the container. It will start the Firestore thing in emulator in the container. And then we need to tell our application where that thing is running. We cannot do that statically because we don't know where that thing is running before we actually run it. Because the container can be started either on the local machine through a local Docker environment or in a remote Docker host, or if you're using Windows, there are the different configurations with Windows Linux subsystem and so on. But luckily, that is not an impossible problem to solve because we have those abstractions for our emulator things. So what you can do in the configuration phase for your tests, for Spring application, for example, you'll do that through the dynamic property source methods. You can ask the actual emulator instances where they're running. And because they provide you with the API, because it's just a Java abstraction around running the particular Docker container, it gives you the convenience API to use that in your application. The example of using the Firestore is available by that URL. It's a sort of a workshop from Google team, which you can try it out. And it works with the emulating Firestore options, and I think some sort of image processing. I'm not going to run this because I would like to go to AWS, which is probably the most popular cloud provider currently. AWS team doesn't provide you with the emulators, which is a little bit unfortunate. They could, because that would be very, very convenient, but they don't. So what exists is the third-party technologies that are emulating the AWS stack. This project is called Localstack by the company called Localstack with the website Localstack Cloud, but there is no cloud part to that, as far as I know. What they give you a Docker container with a local version of AWS stack that you can run locally. So there are a number of services. It provides, they claim that it provides the same API and services that you get in AWS Cloud. And it is a very, very convenient way to test your applications or verify the application work or develop your applications locally without actually hitting your cloud accounts. I know that they execute quite a bit of tests, and the compatibility levels are reasonably good. Well, in my experience, they are compatible, but your experience can vary. So check it out. But usually it works very, very well. So what is great about Localstack is that it can create everything in a single Docker container. And if you can run something in a Docker container, you can run it with test containers, which is a more convenient way than running things locally. Programmatic API gives you the flexibility to do things many times instead of just having static configuration, and tweak what environment you want to have for your particular tests. So I have a number of examples here where we look and use Localstack, and I want to show them to you. So let's start with the simple one. So we have a Spring Boot application. It doesn't matter that this is Spring Boot. It doesn't have to be a Spring Boot application. But what we have is, in our POM XML, we have imported the test containers BOM, which will give us the test containers dependencies. And we added the test containers dependencies for the JUnit integration and for the particular Localstack module. Now, with those things in mind, we can create our tests and use the Localstack, create the Localstack containers in our application. So what we're doing here, we are using the Localstack container abstraction. We specify what version of Localstack we want to run. And we can configure which particular services from the AWS stack we want this Localstack instance to have enabled. This is clearly an optimization. If your test doesn't need anything besides, for example, S3, you don't have to run and enable Lambda or anything else besides S3. But you can have the complex environments where multiple services integrate and work together. You create the container. The second part, what you need to do is to manage the lifecycle of it. In this particular example, well, what you can do, you can manage it manually. I can, for example, call start or stop on the container. But here we use the JUnit integration. We mark our class with test containers annotation. And we mark our container with the add container annotation. And that ties the lifecycle of this container to the lifecycle of our unit tests. Static instances become sort of one container per class. So sort of the container will be started in the before all and stopped in the after all methods or equivalents. Instance fields become equivalent to before each and after each. So you can have a very high level of isolation up to where every individual test can get a new version of the environment. That is maybe an overkill because, well, starting up the containers takes a little bit of time. Allegedly, less time than provisioning the services in the cloud, which can take more time, but it still adds up. So a good rule of thumb is probably to start with either a single phone container, which will be shared across your whole test suite, or at least with some sort of container per class or container per like a number of classes for the thing. After that, after we have the container, after we have the local stack and manage the lifecycle, we need to configure our application tests to use that. So for Spring, we just need to override a couple of configuration properties. And we use the same local stack instance, this Java object, to ask what's the endpoint for S3, and we put it in. We don't even know what that endpoint looks like. We can of course like print it out or like debug the tests and check it out, but we don't have to. We provide those configuration dynamically. And notice how, as an application developer, I don't need to know how to run Localstack and containers. I can look. I think it might be you need some ports and you need some configuration, and then you need some more configuration, and then you need some more configuration for API usage. But the good thing is, I don't need to know that. I can just use the abstraction provided by people who actually looked into that and know how to run the particular technology. You, of course, can override that because this is just Java code. As a developer, you do that at least 3 times a week. But you can run it. So here what we do, we create the local stack instance. And then in the before all method, we also create the buckets for our S3 implementation. This is sort of similar to how would you create the database schema before running the tests. And then the test itself uses the proper actual code path that you would use from your application to do and verify whatever functionality you want. So here we just use the normal S3 template from the SDK. And then we just do things. We send objects into the bucket store, and then we verify that the objects go and get in there. We can run this test. I want to show you how it goes. So what Testcontainers does initially, it discovers a Docker environment that it can work with. And then if the images are not available in the Docker cache, it will pull the images automatically. You can pull them from Docker Hub. You can pull them from your private registries. You can configure that both in the test itself or like in the general configuration, what exactly you want to use, or through the libraries. If you are sort of the platform engineer that wants to create the best developer experience for your people, you can provide them with a little library that will encapsulate the Testcontainers configuration. The test will download the images. The test will start the images according to the configuration. So here we will enable the services. And then we're going to run the test. We're going to run our application, and it will talk to that local AWS stack normally, verifying that we can store and retrieve the objects from S3. You can note that the only sort of way where we change how our application runs instead of the production, as long as we trust local stack to be a compatible implementation of the stack, the only thing that we do is we change the configuration where our cloud is running, and then it works out of the box. So this is a simple example. A more complex example would be maybe if we can run multiple services. What do you think? Can we run multiple services? Here's a sample project from my friend Jens Knipper. He works at Open Value, and very recently he did a little bit of research how to test AWS Lambdas with Localstack. And I'm going to use his repository because it's a really good example. So here's the application. It's a Lambda, which is the serverless thing in AWS Cloud. I'm sorry. And what Lambda does is it takes objects from S3, images from S3 files, it resizes them, and stores them back as a thumbnail into S3, which is a small but contained, but a decent use case for a Lambda, maybe. So what do we do here in the component test? The Lambda itself is fairly trivial. image service is responsible for resizing the image. Storage service is responsible for talking to S3. Event handling service is responsible for handling the events and actually doing the whole thing, getting the objects, resizing the images, and storing the objects. And here's the interesting part, is the test. What do we need for our test? We need an environment where it runs, which is Localstack. So we're going to take the Localstack container, we're going to configure it. We're going to configure it with multiple services because we want to test the both S3 integration and Lambda integration. Then we're going to create the Lambda, the network for Lambda. And then we're going to also bind or put the files that we're going to use for creating Lambda into the container. So which we'll do. Of course, the test will run only if you actually build this application first to actually have the Lambda. Not the Lambda, have the jar files that will be used to create Lambda. But that is a minor concern because you're going to run the tests and there will be a build first, which will populate the target directory. So we create the Localstack container, and then in the before all, again, one instance for Localstack per class, we start the Localstack container using a nice utility function that can start containers in parallel. If we would have two local stacks, or like a local stack and say, for example, like a Google Cloud module, if your test requires both, then they will be started in parallel, which is a nice little trick. So we have start with local stack, and then we create the Lambda function before we actually going to execute the test that exercises that. Creating Lambda function is interesting because this is just using the SDK and configuring the SDK to set the create function request, which gives the necessary name, the runtime for the Lambda, specifying the handlers and how the Lambda will behave, and then providing the actual body of the code that will be our Lambda implementation, which is the jar file. And then, so you build the Lambda request, and then you just create the client, which is the SDK thing, and then you create that function. So before you run the test, you actually create the Lambda function and sort of deploy it into your this current local stack instance. And then the actual test comes. Where's the actual test? Here. The actual test, which is in a typical developer fashion. The only test that's here is testing the happy path. In normal circumstances, I would recommend you to test also negative paths when something goes wrong, or maybe like medium negative paths where your state in your database or your state in the cloud is maybe a little bit inconsistent. For example, what will happen if we call this Lambda for resizing images with objects that are not in S3? It will probably fail with some like random runtime exception, which is not what you want, or maybe it is what you want. But here what we can do, we can run this whole thing, and it does exactly that, which is very interesting, I think. So we are determining the environment for where we run the Docker. I run my tests here with Testcontainers Cloud, so I don't run my Docker locally. Currently, my local stack instance will be run in the isolated VM on the GCP cloud, 100 milliseconds away from me, which is a little bit high for the latency. We aim for the edge deployment, so the cluster where the containers are run are near to you. But it maybe could be eliminated with using like a wired internet and not relying on the conference Wi-Fi to go to the cloud. The good thing is, like, if I would rely on the conference Wi-Fi to actually pull those Docker images here, that will never happen. We would be stuck downloading the gigabyte of a local stack image. But because the containers run in the cloud, it's very nice. So cloud-to-cloud download is very fast. So what we are testing here should be seeing some logs. We are creating the buckets. We We're creating the buckets. We're creating the mock Lambda function from the local stack service. We are creating our function, which is the code where we package our jar file into the local stack instance. And then we start and run the code. And the happy path works. And you can notice that it's not even that fast, that slow. So most of the time is spent on initializing local stack and preparing the services. So we have a larger test suite. That time will be amortized across the tests, which will be much, much faster. The good thing here is that my test runs locally. So what I can do is runs in my IDE as a normal unit test process. So what I can do, I can put any debug breakpoints. I can stop the test execution. I can check what is happening inside my containers. I can check what is happening in my code. In case of Lambda, well, it's a little bit harder to debug Lambda because it's a packaged application that goes into the thing, sort of similar to how you would test like a Java EE application deployed into an application server, which you can also do with test containers. You take the container, you say that you're going to run like a wildfly application server image, and you're going to deploy your WAR file in it, and then use tests against that particular instance, which is very similar to the Lambda use case, but not as modern and maybe a little bit heavier, both on the resource and everything. Right, so we can test multiple services together. I wanted to show one more thing, which is a very cool thing, and then Daniel left, but we're gonna tell him that he left too early because I want to show you a little bit of a Quarkus integration. So here I have my Quarkus application that deals with fruits. It's a Quarkus application. It deals with fruit. You can save fruits, and you can get fruits. And those fruits, they go into the DynamoDB. So DynamoDB is our backend for our fruit-saving application. It's a Quarkus application. So Quarkus integrates with test containers out of the box. So you can run your Quarkus tests, and they will provide you with the versions of environment they think is appropriate if you don't have anything configured. It is called Quarkus Dev Services, and it will work both for your integration tests and for your local development mode. For example, here, if I run this application, wait, how do I run this application? View? No, wait. I don't know how to do it in the presentation mode. Terminal. Terminal. Yes, OK. Right? So if I run my application here, which is a normal Maven Quarkus application, Quarkus dev, it will run in the development mode. And what it will do, it will look at my application. It will figure out that it wants to work with DynamoDB. It will figure out that there is no configuration where my DynamoDB is, so there is no cloud account configured, and it cannot go to the actual cloud. And it will prepare an ephemeral environment for me to run using Localstack. Quarkus Dev Services also work with a number of other technologies, so there are modules for normal databases and Kafka and Elasticsearch and so on. But in this case, they will provision me with a local stack, currently Localstack latest, which might not be the best practice because you, strictly speaking, want to pin your dependencies for the environment as well. But it works, and they will start my application. And now I haven't run anything, but I have now my application running, and I can access it, and I can also send requests to it. So for example, if I now will get my fruits from the application, it responds with an empty, because we didn't populate our database anyhow. And if, for example, if I try to send post request to my Quarkus application with fruits, what it will do, it will take that, it will put it in the DynamoDB running in the local stack container, and and then it will save it. And notice, this is not the tests, right? This is just, I literally just run my application, which is an incredibly powerful thing because it doesn't allow me to forget to run my environment for the application. So as a developer, I can just clone the project and just run it. And the databases or message brokers or anything will be provisioned for me. If I run multiple projects, they will, most normally, they share the containers that they run in. So if I run 2 services against, and they both need Kafka, they will connect to the same Kafka instance, which is very, very cool. Honestly, I don't know whether that works with Localstack. I have my suspicion why it might not, but it also might work because this is the integration on the Quarkus side, how they implement it. So, but this is really, really cool. You can run your application, and when you run my application integration tests, it can also either provision that for me, or it can I can still override the configuration and say which particular Docker containers I want to run. But Quarkus has a state-of-the-art integration with Testcontainers for local development, which is very, very cool, I think. So let me stop this application. Now, what would be very, very cool if this similar thing would be available for Spring applications? Wouldn't it be? It would be very cool. It's currently not, strictly speaking, available for the local development. There is an issue on the Spring Boot sides to maybe investigate the a local development approach with test containers. Quarkus has dev services. Micronaut has Micronaut test resources, which takes a little bit different approach to the same concept of creating the ephemeral environment for you to run. But it's a matter of taste. And Spring doesn't have a generic solution yet. It's a little bit tricky to do on the framework side. So let's not, it's not me blaming the Spring team, how you didn't integrate with this thing that I care about. It's really tricky. But what is less tricky is your individual project. So for your project, you can do this in literally 10 or 20 lines of code, because you know exactly which technologies you want to run. And most probably, you also already have the configuration for this, because you run your integration test with test containers. So here's back to my S3 simple application in example, where we started Localstack and they just used S3 out of that. Here's what I can do. I can replace, where did you go? Here. I can replace my configuration of the containers using the lifecycle methods or annotations and the dynamic property source configuration. I can replace it with the context initializer. Context initializer is, of course, the Spring abstraction that can be used to configure the context for the Spring context. So what I can do, I can start my containers when I'm initializing the context. I can run any configuration that I need for my particular project. For example, here, the same way as in the test, we create the packets for our application. And then this initializer, I can use it in the test itself, saying that, oh, my test needs to run with this context initialization thing. So I can show you that it runs. The test itself is the same as before, where we just put objects in the buckets and take objects from the buckets. That part is not, strictly speaking, relevant. But the initializer approach would work. See how quickly it downloads cloud to cloud. Very quickly downloads cloud to cloud. And then starts Localstack. Localstack on my machine starts in approximately 8 seconds, I think. But then it starts and the test will work. So how can I reuse this setup for my local application development? Very simple. When I create my application, I need to pass this context initialization. I cannot do that in my main class path, because I don't want my test containers dependencies or other test dependencies to spill into the main class path for a number of reasons. First, they don't belong there unless you really want them in there on purpose. Second, they will mess up various situations where your application is processed statically. For example, generating native images with GraalVM. Any extra dependency will allow extra code pass, and everything will be much harder. So we don't want to pollute the class path, but what we want to do is what we can do. We can create the same application that we normally used. So we had this S3 application, which is the normal Spring Boot application creation. We can use our production class, our test class path. So we're going to create a different entry point into our Spring application in the test class path that will do exactly the same as it does in the main class path, but also use this new initializer for the context. So you see the test was passing. And then, but what I can also do, I can run my application locally. This is a Spring application with a custom hand-rolled integration with test containers for environment creation. And it will start. It will provision my local stack. It will create my bucket in my S3 in Localstack. And because the application actually doesn't do anything, it will not do anything more. But you get the point. You can provision the infrastructure. And the cool bit about this is when I stop this, because test containers cleans everything up automatically, there is no code to stop those things, but they will be cleaned up automatically. So next time I run my application, I can get a fresh environment. And this is very, very useful for local development. Right? I think I can run. Can I run Docker PS? Yes, there are no containers here. Look, no containers. No containers. Which is exactly what we want. Right. We are getting close to the time. This is what I wanted to show you. I want to show you that there are test containers modules that encapsulate technologies that mock and emulate cloud technologies, namely some of the Google Cloud module and Localstack for AWS. I recently learned that Localstack is also mentioned in the AWS docs, so it is making progress. I think before it was not the case. So this is great, great, great to see. We looked at how you can configure running Localstack with multiple services, and that this is possible. We'll look at the examples how Quarkus runs dev services for the tests and for the local development environment. And we looked at how you can roll a version of that for your Spring projects yourself. And we looked a little bit at the Test Containers API to better understand what it offers. Right. So, yeah, I run my containers in the cloud. If you want to test how the Test Containers Cloud behaves for you, you can take a picture and sign up. It's in the public beta, so it's free for all. No credit cards or anything like that required. You just need a GitHub account or something, or Google account to log in and start testing. It works best if you already have test containers-based tests, because it runs containers during test containers tests. If you don't have test containers tests yet, you can get some very, very quickly by, for example, running sample projects from here. Or you can come tomorrow to a sort of a deep dive workshop about integration tests and test containers, where we're going to look at in more detail at how test containers runs the tests and what is possible, and other cool features for what you can use in your tests. That's all that I have. Thank you very much.